Good evening, folks. Welcome to Adafruit Show and Tell. My name is Melissa, and tonight I will be hosting. We're going to go ahead and start out with Erin.
Hello.
Hi.
So I have a pretty fun project today. It is getting to be festival season, and I have gone ahead and put lights in my festival coat. Let me flip it around so we can kind of see a little better what's going on here. So this coat has a couple different systems in it, and I've just launched a tutorial showing how they both work. This system that's lighting up right now is actually a 2D matrix. It's made out of seed pixels that I sewed inside the coat. And then if we watch for a little bit, there's another system that lights up the fun fur trim. So there's another strand of seed pixels that goes just through the trim around the neck and then the sleeves and everything like that. And I'm controlling this with WLED, which is probably my favorite software program right now. The way that works is I have kind of an app right here. It works from over Wi-Fi. So from any web-enabled browser, I can control this thing. And I can just select, presets or playlists that I've set up. It lets you choose your effects. It lets you choose your colors. It's pretty cool. And I managed to get both working at once. So I've got an LED strip that's lighting up here running one animation, and then my LED matrix is running another animation. And this whole project, it was a little bit complicated. I'm using mapping on the LEDs so that this is not a square matrix, but I'm still able to run matrix like square animations on it. So that's kind of what the guide goes into. I've done, 7 or 8 guides on WLED now. And if you haven't used it before, it's rad. It's like free open source pixel controlling software that doesn't require any coding. It just does it all for you. And there's so many, I haven't reached the bottom of it yet after 7 tutorials. So I'm having a lot of fun with this, and I'm gonna head out to see the solar eclipse this week, and maybe I'll light up my coat when totality happens. We'll see.
That's pretty cool. Are you able to get it to do any kind of like scrolling text or anything like that?
There is a scrolling text effect on here. Let me see if I can find it real quick.
Okay.
I haven't, it's kind of neat. Let me see where it's under S, I assume. And there are so many presets that I'm scrolling and scrolling and scrolling. It's really a lot of cool stuff on here. Let's see. It's really scrolling text. There it is. So I'm scrolling text now. You can kind of see.
Oh, that's really nice.
Yeah, it's cool. I haven't
scrolling backwards though. Can you reverse the direction?
I don't know. I don't think it looks backwards to me. I think that my webcam might be flipped.
Oh, that makes sense. Okay.
But I also have not delved into this and figured out how to make it say anything other than the default text yet. So I'm not sure how that's going to work. But this is just running on an ESP32. It wouldn't be too hard to hook it up to, something that was running some matrix code from some of the other projects that we've published. So yeah.
Yeah, pretty nice. Thank you for coming by and showing that off.
Thanks so much.
And next we are going to have Scott.
Hi, Melissa.
Hi.
Thanks for having me. Thanks for hosting. Today I wanted to, I think this is part 3 of USB host Featherwing stuff. I did figure out my issue from last week, and it was that I had debugging UART in and out set up, but I didn't have the input connected to anything. So it was like generating all that junk characters that caused my demo to fail last week. So I'm here with a new demo. I've got the USB host Featherwing, but this time it's plugged into one of the ESPs. I don't even know which one. So that's what the debug output on the right-hand side is. And then on the left-hand side, it's trying to list all the USB devices that it finds. So I'm just going to plug in my keyboard I use for my testing, and hopefully it will list that we have a USB keyboard. Hey! It shows up there. I don't know why it was flickering a little bit, but I'm seeing it. And I think I can actually Control-C it from the keyboard. And then, of course, because the user code stops, the keyboard actually doesn't work anymore. But if I hit Control-D again, it should be able to find it again, which it didn't for a while. But yeah, it works on ESP now. I'm taking a look at Atmel, SAMD, and RP2040 before I make a PR for this. But made a lot of progress after I wrestled FreeRTOS to do my bidding for the USB host keyboard support.
Do you know if it's going to be able to do like serial communications over USB? Like if you
Serial
plugged in
communication?
Yeah, like if you plugged in a 3D printer and you could control it or something like that.
Yeah, so the USB host API for CircuitPython is pretty low level. It's like reading and writing endpoints. So we would need to, or you would need to make a library to do the higher level class stuff.
Oh, okay.
And in fact, I was thinking about this because like PySerial is really common, right? So I was thinking we should make a PySerial CircuitPython library that kind of does that middle layer between what is effectively PyUSB. So that's our host API matches what PyUSB does on Linux computers. And then we could build that like PySerial on top of PyUSB, which would be neat.
Pretty cool.
Yeah, so not yet, but there's example code for HID keyboards, MIDI keyboards, and what was the other one? Mass storage, but there's some bugs in the mass storage one as well. But yeah, it's early days still.
Awesome. It's really good. Thanks for coming by.
Yep.
And next up, we have Jeff.
Hi there. So last week I was showing a project where I'm creating, I've got these old 8-bit Z80 computers. And last week I did a project where you can hook that up to a modern HDMI display. This week I am replacing the keyboards so that you'll be able to just type on it with a modern USB keyboard. This one's Logitech, but anything works. And this here is a photo of the wiring. So here on the port marked keyboard it just takes 8 bits in, and then that's 1 through 8 here, and then the 9th is a strobe to say there's a key ready to be received. And then the CPM computer or the firmware on the Z80 has to notice that signal coming in and grab the key and do whatever it does with it. But this was all really well documented in the old manuals because computers in those days were very well documented. So I'll just tab over here. This is the live view captured through an HDMI converter of this computer. So I can type into it and we can, for instance, get a hex dump of some of the firmware code that's running there inside the computer. And the main thing that I still need is a floppy disk drive so I can boot, because if you hit A to boot, it just says disk error because there's nothing attached to the disk yet. That's coming up soon, sometime in the next couple weeks. I've designed a circuit board for it. But yeah, this has been a lot of fun.
Read off SD cards or anything like that?
So there is this product called GoTech, and it comes in various form factors, but this one has the floppy drive, the 34-pin floppy connector, and it's the size of a 3.5-inch floppy. I haven't used it yet. So the thing that I'm working on, the circuit board I designed, just adapts from this to the specific connector, which I don't know if you could see it in that photo. No, there's a 37 or 39-pin D-style connector that's just a little bit away from the keyboard. So that's the next project. But yeah, I was going to show you just a little bit of the code. I did this one in Arduino because I did a related project with CPM emulating sometime last year. And that would convert the USB messages into an ASCII code and then send it over a serial connection, a UART. And this one just has to translate the key, pull out each of those individual 8 bits and then notify the computer that the code, or, that there's a new key code to read. So like the total amount of code I had to write to change it was really not very much because I had this existing example, which is on the Adafruit Learn system. So I hope to make a little 3D printed enclosure because the wiring here is kind of not great. It's good enough to test that it works, but I want a little enclosure that just acts like a dongle converter from USB to this computer. Yeah, I've been having fun with this, and I think I will probably write it up as another guide, even though it's really, on the one hand it's very specific. On the other hand, it just gives the idea of here's stuff that you can do once you can convert from USB to whatever and kind of connect into the older computing world if that's what you're into.
Yeah, it's always useful
so-
to have a guide because people can adapt it to their specific needs if it happens to be related.
Yep. I mean, I can envision that you could make an adapter to a classic Macintosh or other classic PCs that had external keyboards.
Exactly.
Kind of whatever you would imagine. So, keep an eye out on Learn, because maybe in the next week or two that guide will be written. But like Aaron, I will be headed out to see the eclipse this weekend. Anyway, that's what I got for you tonight. Thanks for hosting, Melissa.
Oh, you're welcome. Thank you for stopping by, showing me
All right.
off your project.
See you around.
I see it. And last we have nanographs here.
Hello, can you hear me okay?
A little bit quiet. Could you?
A little bit quiet here. I can try talking right into it. Is that better?
Oh yeah, much better.
Okay, cool. So we are not in our workshop today. We are at the University of Washington Friday Harbor Labs. It's a really cool marine biology lab up here in kind of the very north part of Washington in the middle of the Puget Sound. We're just on an island right now surrounded by water. We have here a tabletop SEM. This is a Joel Neoscope from about 2007. It was made to be really easy for Japanese high schools to run. It's a really cool microscope, really robust. Its downside is, or one of the downsides of it is it has a it has a 2007 era digital image acquisition system. Resolution is a little bit limited. So we are installing our open beam interface on it. So we've cut some of the cables inside here that carry the scan signals, and we've attached some BNCs to that. So we put a little relay in that lets us flip between the internal scan generator and the external scan generator. And then we're going to kind of put all these connectors on this back port or this back panel right here so that we can just kind of plug all our cables in here. And then we'll just have our board on this, and they'll be able to take much higher resolution pictures with it. They do some wall prints already of some of their SCM micrographs. And we're going to be able to make bigger prints now because we can take higher resolution pictures. So I'm going to take you all around here to the lab a little bit. Can you all still hear me okay?
Yes.
Excellent. Okay, cool. Let me know if I drop out here because I'm going to be walking around a little bit.
Okay.
So this is the microscope, the Neoscope. So you can see the very tiny little SEM column right there. It's maybe 2.5 inches, 3 inches in diameter, so that's pretty small. We've got our relay board right there. We have a wall of fish specimens. So we have mini fish in jars here because this is a marine biology lab. We have a CT scanner. So you take a fish, you stick it inside of this machine, and it spins it around a whole bunch, and it takes a bunch of pictures of it with X-rays. And so you can do 3D reconstructions of the fish. So here's a fish that they've 3D printed after. That might not be. I'm not sure if that's a fish or not. That's something they've 3D printed after reconstructing it from the CT scan. We've got a fluorescence microscope right here. So it has a UV light source, so it can. Is my camera still working? It is, cool. We've got a UV light source, so it can fluoresce proteins that they tag in the fish so they can see what's going on. And then this is what makes this lab so unique, is that you walk right out here, and there's a bunch of tanks. And so they can put whatever they want in the tanks, because we are right on the...
Your microphone cut out.
Through all the plumbing,
Your microphone.
through the floor, or through the drain in the floor. So we can have a bunch of students in here and do research on what's in the water. So we got some. So yeah, that's Friday Harbor Labs. We're really having fun with tabletop microscope. I can't emphasize enough how impressed I am with this thing. Oh, what?
Your microphone keeps cutting in and out.
Oh, okay. I should be closer to my laptop now again, so we should be okay.
Oh.
So yeah. So that's Friday Harbor Labs.
Cool. Thank you for showing that off.
Yeah, thank you for hosting. It's been great.
You're welcome. And see you again, I guess. Thanks.
Yeah. Well, we'll see you again. Probably from a workshop next time. We're going to be heading out of here next week, but we hope to see them take some really cool fish pictures with it. So
Cool. Look forward to that.
bye, everyone.
And that is it for show and tell. And in about 15 minutes, we'll be Ask an Engineer. So stick around for that.